Looks good. So, hi. I would like to welcome you to the 4th Rust Prague Meetup made this year. And at the beginning, I would like to ask who is here for the first time? Okay, nice, quite a lot of people. And is there someone who is also visiting EuroPython this week? One, okay. I was because we had quite a lot of people registered for today, so I was wondering if maybe there are some people coming from this huge Python conference that is right now in Prague. It's about like 1,500 people or something like that. And there are actually quite a lot of Rust talks and workshops and topics and so on. So even in the Python community, some people seem to be interested in Rust. Okay, so as usually, I would like to thank the people that make this possible. So Martin here for giving us access to this beautiful building and to this room, and the Department of Distributed and Dependable Systems, who is kind of, I guess, not owning, but managing this room. And we also have some small support from JetBrains. So I just found out about this recently, but JetBrains has this user groups program where they actually support user groups such as these meetups, and they give them just licenses for the IDEs for free. So we got some licenses for any JetBrains IDE of our choice. I have some codes with me, so we can do some quiz at the end, but it seemed that no one wants these licenses, but anyway, we'll do the quiz and we'll see what happens. Yeah, and my name is Beránek, by the way, but you probably saw that on Meetup or somewhere. As a regular reminder, I would like to tell you that we have this nice little website called rustlang.cz. So if you would like to see what is going on with Rust in Czech Republic, you can check out this website, and it also has an RSS, so you can subscribe and you will get all the notifications of meetups, recordings. There are also some job openings or in Rust from companies or some new university courses and so on. So rustlang.cz if you want to see what is happening. And I would like to, in this intro, I usually just talk about some new stuff in Rust. So what has happened since the last meetup in the land of Rust? It was actually a lot of stuff. But one thing that I would like to point out is this Project Goal initiative. So this was announced on the Rust blog about two months ago. And the idea is essentially that Nico Matsakis, if maybe some of you might know him, he's a very well-known figure in Rust. He's the author of the borrow checker, amongst other things. He's trying to create some goals for the Rust project. Because we are actually, like the governance of Rust is very messy. There's like no clear structure, no one holding the wheel and deciding what we should do. So he's trying to prioritize, essentially. So this Project Goal initiative is, the idea is that we will create some set of goals for the next 6 months. And the goals will essentially represent something that the Rust project is prepared to support, either through code reviews or actually doing the implementation or even funding people to work on these goals. So we will put up a set of things that we think would be good for the project, and then people can just come and we can potentially give them money to work on it, or we can review their pull requests and so on. There is a Rust project goals Wikipedia or just some kind of documentation page, and currently there are about, I think, 24 goals defined, and the list is more or less complete. There has been an RFC posted, when was it? Yesterday, I think. Edurom is kind of sluggish. I think it was yesterday or something like that. And just to give you an idea, what are those goals? So there are 3 flagship goals. One of them is to finish the 2024 edition, which is kind of obvious because we have decided that we will have an edition this year, so we should finish it and do it. This edition will have quite a lot of changes, but that's a talk for another day. And the second flagship goal is to make async Rust kind of nicer to work with, because if you're using async Rust, you might know that there are some missing features, some rough edges, and so on. So the goal is essentially to make async Rust more similar to sync Rust, so implement stuff like async closures, which are, by the way, already in Nightly in a completely new shape, async drop, async generators, and like these kind of features. And the third one is helping the Rust for Linux project. So Rust for Linux is the initiative to allow people to write kernel modules and drivers for the Linux kernel in Rust. And there is a bunch of features that those developers, driver developers need to make it easier. So essentially, the goal is just make it easier. We have already made some progress on this. So for example, as of last month, our continuous integration is actually checking Rust for Linux after every commit. So before, we were breaking the Rust for Linux integration quite often, but now it is actually, like, you cannot merge a commit into Rust now if it would break Rust for Linux. So we have like a bigger promise to these guys that we will support them. And yeah, so those are the flagship goals, like the main ones. And then there is a list of about 20 or something like that other goals. So if you are interested in what are some of the goals that Rust wants to improve in the next 6 months, you can check this web. And there are very interesting ones like cargo script, which is essentially, this is again already in Nightly, it's the ability to run a single file with cargo as a script. So you don't need cargo toml and all this infrastructure. You just have a single file, you put the dependencies at the top, and then you just execute it as a Python script. So I think that will be super nice. Or, for example, make ref counting more ergonomic. Maybe some of you have seen this recent blog post about this guy that was using Rust for creating games, and he was kind of sad about some things in Rust. So one of those things that could be improved is to make like reference counting a little bit more ergonomic, so that you don't need to write like clone, 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 clone 50 times in your source code. And yeah, so I could talk about this for hours, so I will stop. And if you are interested, take a look at this page. And maybe at the next meetups, we can have some talks about this. So the agenda for today. The first talk will be about terminal user interfaces with the Ratatui, which is a very cool Rust crate. It will be presented by Lukáš, Franěk. Then we will have a talk about Nix, which I don't know anything about, so I don't know what it's about, but we will find out, by Kateřina. And then we will have maybe some free-form discussion, something, Rust in education. So as in the last meetups, after the talks are over, we just hang out for a while and maybe discuss some topics. So today it could be education. And then we will have it's not a surprise anymore, but we will have a quiz. I prepared a few questions about Rust, so we will see how it goes. And then whoever wins the quiz will get the prize that no one wants. So that's it. So yeah, so I think we can start with the first talk. Just give us a minute or two to reconfigure this setup.
Dobrý?
Can you hear Lukáš?
Can you hear me?
Yes.
Great. Great. Okay, so welcome. Hi. Before we start, I would like to ask you some questions. How many of you are familiar with Ratatui? Great. Oh, that's quite a few of you. Wow. and how many of you are using Linux and especially terminal for most of your work? That's awesome. That's great. That's good to hear. So today talks I prepare for you. It's about Ratatui, as it was mentioned before. It's a terminal user interface library. It's library to create terminal user interface. But let me start with this. This was my first personal computer when I was really tiny. So as you can tell by this image, I don't have much much time to left on this world. As a tiny person, when I first seen this, which is Atari Basic language, I imagine only one thing: it's a fucking magic. It's the closest to be in the real world to the fantasy magic as we can be, because we are really just trained warlocks that is just communicating with the with the anima crystals, which is really totally amazing. Hello, my name is Lukáš. I've been programming for, I don't know, more than 20 years, and I'm trying to be some kind of a wizard in the programming world. At least I think we all are, and I'm interested in every technical part of technical world. So I'm trying to doing some webs that I started with. Then I moved into the games, desktop applications, also embedded programming, also a mobile. I'm trying to packing some things for Alpine or Arch Linux, and yeah. I work in these wizard towers at least for a while, and I recently found my new love, and it was love for first Hello World. I'm working with Rust only for a couple months, but it is such amazing experience. It's really, there is no better language than Rust, I think, and I can tell only after a few months, fiddling with it. It's so awesome, and so my learning journey just began with Rust. So I would like to talk about how I learn Rust, because it's a correlation about Ratatouille as I get to it. I first start with Rustlinks, of course. I think everybody knows Rustlinks, right? Rustlinks, by the way, in recent version are using Ratatouille for watch mode, for list of those lectures. So you can continue or start from, I don't know, from the middle lecture or task in Rustlinks. And usually when we are trying to learn a new language, we start with the hello world, right? And the hello world usually goes to the output into the terminal. So that's why we have our first CLI application, even if it just only prints hello world. So from CLI, it's just a little step ahead to create some terminal user interface. And for that, I decided to use Ratatouille, because there is really no other or better library in Rust to doing that. And with the combination of Rust and Ratatui, I just made my first Rust application, that is NetScanner. I'm going to talk about it later. So when we have CLI and terminal user interfaces, which is just CLI application, I specifically want to talk about the terminal user interfaces, because usually these kind of applications are just a bunch of tools put into together. So, for example, in my NetScanner, which is just which is scanning the local network, it pings all the clients, check the open ports, and it gets Wi-Fi signal strength and all that kind of stuff. I usually I did it because I was building my own home lab network, and I all the time just putting Nmap, ARP-scan, IV, NMCLI, and all those tools indefinitely and all the time was repeated. So I started to put all those tools together, and that's when we get some terminal user interface or application. Same with the Midnight Commander. It put together like copy, ls, move, FTP, SSH, all this kind of stuff is in the 2i applications that we only can control with some kind of key shortcuts, and not typing all those commands together. So I think that's awesome, and we have of course old terminal user applications like BIOS, for example. That's old stuff, an ancient first 2i application. Midnight Commander, of course, it's from the DOS, Volkov Commander, M62, and all that kind of stuff. It's ancient, but it's with us all that time, and it's the core. I think for us developers to just start with, and it has a bright future thanks to Ratatui. And so 2i libraries. We have, of course, we have ncurses, we have Turnbox, we have 2i Go in all the different languages, Python, Go, Rust, C, all that kind of stuff. But today I want to talk about Ratatui because it's in my opinion the best of them, and of course it's using Rust. that's maybe the main reason for it. Okay, so Ratatui, it's really lightweight, immediate mode graphic library. Immediate mode, I'm going to talk about it later, but usually it's only about, it's not holding any kind of widget object in the memory, and it will render it as it goes in every frame, the whole scene. Ratatui, a little bit of history. It's a fork from 2i RS, which is the old library. I don't know if anyone is familiar with it. Cool. The first version, or at least version 0.2, was released in December 2017, I think, and it was forked since February last year, and it was archived in April the same year. So 2i RS, it's no more. And we have Ratatui, which is awesome, and it's working well. Recently, they got some donations around $25,000 because huge companies are just putting to use in Ratatui, for example, Netflix, Supercomputer Centrum in Ostrava, and all these kind of companies are using Ratatui. Rustlinks, for example. And Ratatui, of course, is handling keyboards and mouse events. It supports various backends like cross-term, Termian, or Termviz, and it has a huge amount of built-in widgets. Well, almost anything in Ratatui is widget, some kind of. And the main strength is it's really simplistic, simple, and it has an awesome dynamic layout system that are using constraints like almost anything. Every other libraries or frameworks are using it. I would start, or I really recommend if you want to start some new project using Ratatouille to use the templates. So of course, cargo generate we all know, or using it of course when we have a chance. If some other project have some templates available, so we just download or install cargo generate. And then we use the cargo generate command from Ratatouille templates. And we have three options that it's really simple with asynchronous call with Tokyo implemented, or template for kind of complex applications that are using components, and that components option is the best, at least in my opinion, because it have implemented like human panics, configurations for keyboard shortcuts. It has implemented Tokyo for asynchronous calls. It really have it all. So I'm using for every project that I'm creating for Ratatouille at least. So I would really recommend go with the components part. But it really depends on you and your needs. About layout in Ratatouille, of course, we are rendering into a terminal, into a command line terminal. So we start at the top left corner and we go to the right and down. So we're populating the screen by its every rows. Yeah. Of course, layout is very easy to use. You just have you just specify the layout, their direction, and with using constraints, we just split the frame or the area we get from the terminal for that kind of frame. It doesn't have to be frame. The frame size in this case will only return the rectangle, which is have x, y, width and height. So we are splitting only that rectangle struct. So as you can see, really easy to splitting, maybe centering some kind of block or something, pretty easy. With the rendering and immediate mode, usually the graphical user interfaces or terminal user interfaces in this case. So this world it's hugely populated with those two ways to render application. Immediate mode is just the rendering part. So we are building and creating and holding everything in our application, and we're just putting those kind of states in, to render to our graphical library to render it. And there's a retain mode, which is different. So that kind of way, it's that the graphical library, it's also kind of a framework which is holding the scene and holding every widget options or nodes in the memory. Here you can see in the simple loop how we can draw the frames or the widgets. It's only depends on a specific condition that we want to have to render what we want to render. So that's simple. We just create the terminal, choose the background, and then we can draw in simple loop or in another asynchronous call or thread or whatever. Here is just a small part of widgets that the Ratatui library has. And there are huge amount of lists, so I just put here few of those. The main block, that is the main construction block that Ratatui have. It's of course block, and here is how simple it is to just create it, and we have the borders, we have the title, and that's pretty much it. Of course, the title can take the vector of titles, so we can have titles just side to side, one another, on the top, bottom, left, right. It doesn't matter. But I just wanted to show you the simplest way how to create the block. Now we have a little bit complex things, like table. By the way, on this image we have all the maintainers, the active maintainers for Ratatui library from that fork. And as a table, we just specified their rows. As you can see, here we have only one row for with three columns, and we specified rows, which is just the data we want to visualize, and the width of those columns. Here we can also use the constraints as we like, and then we just return the table with some column spacing, header, and maybe some highlighting styles. That's possible too. Of course, I forgot to mention that, and I'm sorry about it. There's two kinds of widgets. We have stateful widget and just normal fixed widget. And stateful widget, it's taking its reference, and we can hold the state. For example, when we are selecting in the table specific row, or if we are handling, for example, keyboard or mouse events, we just hold the state for that widget, and then we are rendering it with different call, like render stateful widget, and not just a render widget, which is just fixed or static. So I'm sorry about that additional information. Let's continue with widgets. Here we have a sparkline widget, just for some graphs, And amazing widget that needs to be mentioned, it's Canvas. Of course, we can draw in terminal using code, of course. And Canvas widget, it's kind of same as a Canvas in JavaScript, if anyone knows. So we have lines, circles, rectangles, dots, and all that kind of stuff. And specifically Canvas widget in Ratatouille has one special part or type to draw, and it's a map. It's a world map, or you can specify some continent or part of the world, and then you can draw it like this. It's just it's amazing to be as a built-in widget in Canvas. So next we have a list, which is also one of the most used widget. Personally, I'm using more tables than a list, but it has its own pros and cons. It's kind of the same code like for a table, so I don't know. And here is a list of all Rest built-in widgets, and under that line, it's the third-party widgets. It's not a complete list because new widgets are made day by day. So I really can catch them all as we can talk about it. So yeah, that's pretty a huge amount of widgets that you can use. And when we put all together, we can get some beautiful applications. So here is just a showcase of some of them that I found very interesting. Let's start strong with some Krabby-Gochi, which is just a terminal Tamagotchi. So we can have some friendly crustacean companion in your terminal. So that is something. This is really something. It's somebody just made a neural network that in terminal using Ratatouille that's learning playing Snake. And the visualization, it's just amazing at this application. It's just showing you the moves and the logic of thinking or something like that, and it plays the game itself. It's really something. This is just amazing thing. Unfortunately, I cannot show you as an interactive demo because I don't have a drivers and graphical drivers in this piece of old tech. So somebody just made Ratatouille Bevy render widget, which is just headless engine, and that is just rendering in frame buffer some kind of 3D scene or whatever you can render. And because we are using terminal, which is have a GPU acceleration support, and we can render images. We can just take the frame buffer of our Bevy engine in a headless mode, and just put that frame buffer into the bitmap of our image in the terminal, and voila, we have 3D scene in terminal. That's just great. Open API terminal user interface. If anyone knows Postman, I always wanted to have Postman in terminal, so now we have it. It took OpenAI specification for version 3.0 and 3.1, and we have this amazing tool that we can just put the endpoints and just try to test it or see what's in the body and all that kind of stuff. If anyone knows Yazzi, all right, how you pronounce, also made in Ratatui. It's a Ranger kind of style file browser. It's pretty quick, and it also have image previews in terminal. So that's the next amazing tool. Using Ratatouille. And if anyone is using metrics like communication client, and of course are familiar with Vim key bindings, this is the tool for you, because we have metrics client in terminal that is using Vim bindings. It's supporting transferring files, showing images preview, and many more. So I would really recommend with EM, that's an I, not L. And there is just hundreds and hundreds more tools and programs and applications that is in the awesome list. Also in Ratatouille organizations that I would really recommend to go through and just pick your own choosing. What do you want to use? What do you need to use, and all that kind of stuff, and maybe just for some kind of inspiration for your own terminal user interface that you're gonna do with Ratatouille. So that's kind of it. I have to be quick. So Ratatouille, you have all the links in here. Join the Discord of Ratatouille, because there are some channels named Freshly Made with Ratatouille, and there is every day new stuff, new amazing things what people can do and doing with this. So yeah, I recommend it. And if it's not obvious now and enough, this whole talk and presentation, it's made in Ratatouille, of course. it's in terminal, and I wrote it specifically for this talk. And the slides are in my GitHub, so you can clone it, you can see it, you can go through the links that are in those slides. And thank you.
Thanks a lot, Lukáš. I think his enthusiasm for technology user interfaces is clear. So,
Jo, promiň.
Maybe we have some questions?
Yeah, sure. I forgot. I was thinking that there's not going to be any questions.
Have you also tried Perceive?
No.
That might be interesting to compare, because it's also a mature UI library, but it takes a declarative approach to UI. So like manages your application, you subscribe to events. And it's a really different way to do stuff. I found it that if you have like those level application, the type that you have just a lot of nested menus and screens,
Yeah.
that they are really easy to do in Perceive, but harder in UI. But I think that UI is far more flexible, so it's something that might be interesting to look into. Also, what's your window manager?
i3. Of course. The cursive it's written in Rust.
Yeah.
Okay. That's the main.
Back in the day, they were the major
Okay, okay. Thanks for the tip. I will look into it. Anyone else?
Thanks for your talk and thanks for showing us the demos and samples. I have a question regarding the visuals now, because according to my personal taste, it's sort of very bare bones. I mean, even compared to things like Turbo Vision, 30 years ago, it's sort of bleak. So is the visual style hardwired into the framework, or is there a way to stylize it and change it?
There's no hardwired in the graphical library. What will you do? You do, and it depends on the amount of work and energy and time you put into it. Of course, I didn't mention it's a kind of new crate that is some kind of shading language for terminal effects and all that kind of stuff. So I didn't have too much time to spend on this presentation tool to be, some amazing, like awesome, maybe window manager or something like that. I didn't put too much effort into the design. I just trying to, implement some widgets into it and put it into some kind of presentation form, at least for information. So yeah, it depends on you how great or nice you made it.
All right, but I mean, my question is there some kind of centralized, so to speak, way how to change the visual style, or you want to have a different visual style, or to just implement your custom widgets?
The center or centralized type of style, it depends on your theme and on fonts that you are using.
So there is a theming.
Yeah, sure. You specify the colors of anything you want to render, and the installed or the configured theme will, of course, be as a main thing that will override those colors. So yeah.
All right, thanks.
And of course, the Unicode, the glyphs of the fonts that you are using, that is the main factor, of course, also. So yeah.
All right, thanks.
So thank you for the talk. It was really amazing.
Thanks.
Fascinating also that you made the presentation with I have a look at the slides.
Yeah, sure. Clone it. It's on my GitHub 2i slides. So.
My question would be, do you have any experience with Ratatui on Android?
Yeah. Somebody made the issue on my. Yeah. That's it. I made this network scanner, and somebody made an issue that I should port it into the some Android terminal. I don't know what is it called. Yeah. So something like that. But I didn't have much time for it, so that's postponed. Until I found some spare time to have a look at it. So, but it shouldn't be a problem because we can build it with muscle, and it's for arms and for really static compilation of all of those libraries. So it shouldn't be a problem. But I haven't have a time for it. So yeah, I'm sorry, I cannot answer you. Anyone else? Okay.
So maybe about performance.
Yeah.
Number one, does it do new allocations on each frame? And also, does it do some kind of diffing, or does it just redraw the screen?
It redraw a screen every time it should redraw, of course. Right now, the tick for update and for a draw, it's specified in the components template as I talk about. So we are drawing, I think only 10 times per minute or something like that. But it depends on you. Of course, the performance we are talking about Rust. So whatever you hold in the memory, it depends on you. And performance also it depends how multi-threaded your application will be in. And yeah, the Ratatui it's pretty lightweight. So for example, I have as you saw that I have many images in my slides, but still I'm dropping every image for every slide. I'm creating new, and yeah, it's working. It's taking only, I don't know, 0.5% of my lame CPU and only 10 megabytes of RAM. So I don't know. It really depends on your application.
Yeah, I took the liberty of showing Lukáš's net scanner here so that we can see it in action. That it's not just an image, but it actually like does a lot of stuff, and it's these nice animations, and you can change the visual style, maybe even more than this, but you can use colors. That's very
Yeah,
good.
sure. You can use the themes as we spoke about, and that's the easiest way to change the theme as itself instead of go through some configuration file and configure every type of title or anything else. So yeah, fonts and themes. Okay, thank you so much.
So let's thank Lukáš once again. Can start with the second talk. So let's welcome Kateřina. Let's hear about Nix.
Hi. I will just start the presentation. By the way, this menu already is made with the Nix dev shell, so it's a small demonstration of capabilities of the whole thing at the beginning. So, hi, my name is Kateřina, or Kate for those who don't want to deal with the cursed letter. I am a Rust developer for around 5 years. I'm a Nix user for around a year and a half. And I really love the tools that it provides and how it helps me with the daily work. So when I went to Rust Meetup, I was like, okay, so what should I talk about? Like, which part of Rust should I speak about? And obviously, I decided to talk about something that is not Rust at all, and it's a completely different programming language. On the other hand, on various conferences that I've visited, especially on Eurorust, there was Nix was a really big topic during breaks between talks, and from the overall Rust community, it looks like there is quite a huge adoption, and people are quite Nix curious overall. So let's see what it's about. I would ask you, how many people here know about Nix? Oh, that's okay. How many people here use Nix? Okay, that's use it in production. Okay, then you might know about it even more than I do. Well, I used it in production in my previous work as well. I was building CI with it and stuff like that, and it's quite useful. So we'll start with the beginning, like what it's about, what is Nix. On its own, Nix is a purely functional programming language. It's lazily evaluated. It's also a package manager, you could say, and build system. And it's multi-platform, which is really important for this use case because it runs not only on Linux and not only on Nix OS, which is a distribution of Linux based on it, but it runs on basically any Linux distribution. It runs on macOS, and unofficially it runs on BSD as well. And this quote, I don't know where it's from. I've seen it for the first time on a talk on FOSDEM, and even there it was unclear where it came from. But every simple configuration language will eventually end up being Turing complete. So Nix is kind of jumping over it and going, well, yeah, let's do a functional programming language for it all. By the way, one thing, don't be afraid to interrupt me because some stuff there is quite complex, and it might be easier to deal with it sooner than later. Which brings me here. What is Nix not? Nix is not easy to learn. Nix is not well documented. It's something that we are all aware of. And it's not opinionated at all. There are plenty of ways to do some stuff. You can take this approach, that approach, which is also part of a pain point, I think, because you can. The official documentation is often outdated and not great. There are plenty of blog posts and plenty of articles from Nix enthusiasts that are really great, but plenty of those take some approach or different approach, and it takes some time to learn the fundamentals and know what to use and how to do that. So yeah. What is it for, or what is it good for? Well, it has access to huge repository of various packages, and I think that I've seen a graph some time ago with a number of packages, and Nix already overtook even Debian, which was quite known for having huge repository. And it makes it really easy to build new packages. If someone of you used, for example, Gentoo, and knows how easy it is to write an e-build, it's basically the same difficulty to write a Nix package. And well, if you know how to do that. It provides a declarative way to define builds and build environments and their configuration. And again, it brings us back into the Turing complete configuration. Just as a small example, which is more from the world of Nix as an operating system, my friend loves to have all of her shell applications themed the same way, but each shell application has a different theming approach, and she wrote a package that is evaluated in her system build, which takes her theme definition and basically builds configuration files for all of her terminal apps that she uses. So she adjusts her theme on one place and basically programmatically changes it everywhere, which is amazing. And you can do this with built environments as well. And because of the way that it works, it allows coexistence of various versions of software and libraries on the same system, which is something that we are used to with Rust, and for example, is quite a pain on in different ecosystems. For example, with Python, it's kind of easy to bring package to basically system scope or library to a system scope, and then deal with conflicts and stuff like that. There are tools that are solving that, but Rust and, for example, Node.js solve it by basically having repositories and packages or libraries scoped to your work directory. Nix does it slightly differently, but yeah, if you are managing your built environment, you want to have your dependencies, and you want to have your environment stable and basically the same across various computers. And with Nix, with Rust, it's possible to do thanks to cargo lock, and you have the same libraries, but you still don't bring over the same Rust version. You don't bring over the same OpenSSL version. If you are using OpenSSL, you don't bring over all other things. You can do it with Docker, but it has its issues, advantages. This is just a different way to do it all. So how it's all done? Basically, the basic building block of Nix is a Nix derivation. It's package, so to say, more like build definition. It's basically a program in Nix that gets evaluated and spits out a package that is built, if you call it. When you evaluate it, or when you basically call the function, it also creates a store derivation, which is saved in your root in a Nix store. So yes, if you install Nix in any Linux distribution, be prepared that you will have /nix/store with all of your packages. And the ability to have different versions at the same time is caused by those packages having being prefixed by a cryptographical hash. It's a hash that brings together all inputs of the derivation, the name and the output, and puts it together to this unique path, which is interesting in a way that it allows you to not only have like various versions of the same library or the same package in your system, but you can also have the same version in the sender state, in the sender meaning, but with different patch set, for example, or different features built into it. Basically, you don't have limits there. Another thing that is really important specifically for development environments is Nix Flake. It's a fairly new concept. I think it's 2020. I'm not sure 2021. I've heard the first mentions of it. Not sure. Doesn't matter. What does matter is that it's still unstable. You need to enable it as an experimental feature, but it's widely used everywhere in the Nix ecosystem and among Nix users. So I wouldn't be afraid that something breaks or that something fundamentally changes and you would need to completely remake all of your definitions and Nix flags and everything. I don't think that there's a reason to worry about that. What flags bring, and one really important part of that is that it brings log file version pinning. The same way as cargo log locks your dependencies, flake locks your dependencies, and you can push your log file into your repository, and you can build everywhere with the same versions of everything and update only when you are ready to update. I don't know if you have you've had that issue sometime, but for example, we've been building our Rust packages and testing periodically in CI with the latest Rust crate, and sometimes it broke because new Clippy version, new lens and everything. Obviously, I can also pin my the version of my container for the CI, but this does everything on one place, which is quite nice, I'd say. And because it has the log file, it allows reproducibility. So everywhere you bring your development environment, it will be the same. It will rebuild to the exactly same state as it was on the other place. This is a really simple Nix flag and how it looks. It basically takes inputs, which are inputs of the Nix flag. In this case, I'm taking in Nix packages, which is the repository of all packages in NixOS. As outputs, I just did a really silly thing and defined two output derivations, as you can see, default and foobar. And I did just equal, one equals the other one. Basically, this channels the derivation from Nix packages to the derivation in my flag. That's basically everything. And if you, yes, I assume that you see it well. So one of those packages I'm bringing there is hello. So you can see I don't have it installed. If I go Nix run, it runs the default package, the hello world. I can also obviously run the other package, which calls the nice, which brings out the fortune package. It's just a really simple example. I'm not building any packages here. I'm just toggling them from one place to other. Basically, the inputs and outputs in Flake work like this. I have inputs, outputs in some flakes. I can bring them to another flake, combine them, use them in my build process, build something else. Eventually, I can feed it to another flake. Basically, you are just calling one function and evaluating it, evaluating other functions that you call from it. It's simple as that. Which brings us to the developer shell, which is why we are here, because you are not building packages for NixOS, I assume. The developer shell is started with, when you are using flakes, you can start it with Nix develop. It develops all derivation dependencies, but not the derivation itself. So if I call it in the previous one, it will bring me to another shell, but it will not have anything there because I'm not actually building anything in the flake. I'm just bringing packages in, so it will not do anything basically. But if you are building something with C++, for example, or Rust, it will bring up all tools that are used to build that flake, which is important because you can start your environment there. Another tool that it goes together with is Nix Direnv. Nix Direnv is a really simple program that basically hooks up into your shell and it triggers every time that you change your directory, and it looks into your directory if that directory is a development environment. If it is development environment, it will automatically activate it, so you don't have to deal with anything. You just cd into your project, and your build environment will execute, which can be just like bringing in Rust, cargo, and everything, but it can also mean launching, for example, a PostgreSQL server on background or anything, really. There are frameworks that make it slightly nicer for us. It's just libraries that are used for building the flakes, and in some cases they really help with the development environment as well. Flake-utils is probably more used, I'd say. I prefer Hercules CI flake parts because it is a nice and really modular framework that allows you to bring up modules. I will show you how it works really soon. Just bear with me, please. And it's one of those modules that are parts of flake parts or are usable from flake parts is NCI, Nix Cargo Integration, which brings us to where we want to go. So this is a basic flake parts project. It's a bit more complicated than it was. It's still a hello world package. One important part and one part that is kind of hard there, not hard, but just lots of boilerplate are systems where you need to define for which systems is the package does the package build. You can also define some exceptions because some things are built slightly differently on macOS, for example. But the important part is Rust. So NCI is cargo integration. From the name itself, it's kind of obvious that it actually uses cargo and integrates with it. It actually uses log file to look at the package itself and look at what exactly is which packages or which crates are in the workspace and stuff like that. This is just simple initialization or initializing inputs of flake parts. This is the main body. Again, we are getting into slightly more complicated waters here. Here in imports, we are importing not only NCI flake module, but also another file flake crate snakes, which I created. And I will get into that file now. It's just initializing the NCA project. Important part is here. Here is the crate name. Obviously, I assume that you can already imagine that let is basically a definition of variables. So I'm just defining crate name so I can reuse it. I say where the root of my project is, because it doesn't have to be always the same directory as the flake. Here I could put various configurations of build, for example, libraries that I want to bring into the build itself and stuff like that. Here it's empty because it's just a simple hello world. I don't need anything else. I just need to build a Rust project. What this does is that it generates a derivation for my project for me. I don't have to do anything. I don't have to specify it in any other way. I can just call it the same way that I called derivations from Nix packages in the previous example. And it generates the dev shell as well. So here I just define that the dev shell is the dev shell of the crate outputs, which are in config and CI outputs and name of the crate. And also the default package, which is the package that I want to, that I'm building here. One thing that you can notice here is that I don't even have cargo installed in my operating system. Heresy, I know. I don't even have Rust up. If I go into the NCI folder, which is my NCI example, you see that something happened already. And I have cargo. If I take a look, where is cargo actually? It's a really pretty path. If you want to know where it comes from, here, the path variable is really big. So I have cargo. I can do cargo build. My package will easily build. This was too fast, but Rust doesn't build this fast. Okay, it does. Well, it's a hello world. I can also do cargo run. I can also do Nix run because I defined it as a package. This takes a bit longer because it is building it as a Nix package, not as a cargo build. But it works. This is not everything that you can do with it, obviously, because that would not be exactly worth the effort. So why all of this? You can have reproducible development environment with Pinterest versions and versions of all other packages. You can have predictable dependencies, and you have plenty of other tools at your disposal. And one thing that I really love about this, it allows you to really simply generate lightweight containers, which if you use it in production for deployment of some services, it's just amazing. Actually, when it comes to the OCA container, if you look here, here's the default package still. So packages release. But here, I'm defining a new derivation, which is my container. The name of the container, I can take it from the variable itself, tag latest, obviously. This is a configuration of the container. So I don't have a Docker file, I don't need it. The command that will be called from the container is the package bin and migrate, which is the binary that it uses. As you can notice, I don't know if you see it, but I don't actually install the package itself anywhere here. I just use it as a binary. That's because by having it here already, I'm already evaluating the next derivation, and it already brings it into my next star. So I don't even have to explicitly install it. I just use it, and it's already there. And how it works. So when I go Nix build container, it will obviously take a bit of a time, but shouldn't take that long. It's small. Because in containers you usually base them on some Alpine, Slim Debian, or anything. But here we are building something that is really, really small. How small? 41 megabytes. It's a hello world. We all know that hello world in Rust takes a lot of space if you don't strip the bug symbols. But I don't think that it's that much bigger than the hello world would be on its own. And yes, it's the container with my package. It works. I can obviously make the build slightly more complicated. I can bring their configurations and stuff like that. I can show a slightly more complicated one in one production project that I've had. This is a menu that is created by a dev shell module, by the way, which is also nice. I can define specific commands for my build environment that I can launch. So I can run all of my CI tasks. I won't be running them. It would take quite long on this project specifically. But I also have a container export command for exporting container. In a different project, I have a command that already brings that package to my takes that package and uploads it to my Docker registry. You can even, because it's a programming language, you can even have secrets there that are encrypted by your SSH keys. So you can even bring your, technically you can even bring your secrets to your storage there and just unpick them anytime that you enable the environment on your computer, but it won't work on any else. Like, the possibilities are quite limitless here. I know that it was quite a lot, and I don't know if you got everything. So does anyone have any questions about all of this? Do I use what? Cargo what? I'm sorry? Yeah, I use cargo, yes. The NCI only uses cargo for figuring out which packages are actually in your workspace, so which packages can be built, and and obviously if you like, I don't use cargo directly in my when I'm building Nix packages, or if I'm building the containers, because that is handled by NCI, which uses cargo obviously, but it's all behind it. But during the development itself, I obviously use cargo because it's just more straightforward. But I'm bringing the cargo in, and basically all settings of the environment are provided by NCI. I can also define, for example, Rust modules themselves for the NCI, so I can save the like which parts of Rust or features of Rust do I want to download with it as well.
Can you also use it to manage your Rust item for the version or something like that?
I'm sorry, can you repeat that?
If you can use it to automatically download the Rust monitor for the version.
Yes. I think that I even have Rust Analyzer defined in this one, actually. Yes, this is a definition of NCI toolchain. As you can see, I define that I want to work with stable Rust, which is default. But when I was already defining the toolchain, I wanted to be more specific. I'm bringing Rust STD. I'm bringing Rust sources, because that's something that's required by JetBrains tools, actually. I think that Visual Studio Code with Rust Analyzer doesn't need it, but JetBrains does. LLVM tools, because there are nice coverage tools in it, which is not a default Rust component, I think. So yeah, you can define basically everything. Other things that you can see here is that I also bring in the configuration of the project and copy into etc. That's a really interesting build flag. I was testing something, I think. Runtime specification of runtime libraries, because I need OpenSSL.
How long is this file? How long is this file?
Only 102 lines, and I should honestly split it, and I could throw away some stuff, but it was like an iterative approach, and this was my first project where I built like more complex management. So I'm not sure how it compares to your pipelines and to your next. I would assume so, yes. Well, this is only one file. I also have a dev shell one, which defines the development shell. But it's also not that big.
I think there was a question in the back.
Mm-hmm.
Yes, maybe you get it, but when you show the grapes names,
Mm-hmm.
dependencies, are those actual Rust dependencies, or are those just vendor libraries like OpenSSL? Like if you depended on Axon or anything, would you write it in your cargo terminal and in that grapes too?
No. I don't need to write Rust dependencies. Those are installed normally from cargo toml.
Okay. So it's just for like vendoring OpenSSL and stuff like that?
Yes. So you basically have, you basically have two log files. You have log file for cargo and log file for Nix. I'm sorry.
Okay, so it's really nice to see like a completely different approach because we're using Phoenix, plate utils, and well, Grain. It's slightly different, but it's really nice. My question is, have you experimented with cross compilation and building for different targets?
I didn't build for Mac. But I do have one Nix flag that deals with cross-compilation to RISC-V MCU.
And those tend to work really great, right? You just specify the target and it pulls in everything. That's one major bonus, I would say, if you're doing cross-compilation a lot, and it's going to be really great for that because you don't have to worry about the C2 chain. You can pull from somewhere, you don't have to build it, install it yourself.
Yes, that would be worth mentioning. Thank you. One thing that I noticed is slightly more complicated, and I came into that conclusion when I was working with MCUs. I was trying to build the SDK for expressive chips and specifically for Extensa, which sadly doesn't use upstream Rust, but they have Rust and LLVM forked because the Extensa, I think that it's getting into upstream LLVM at this point. It's almost there, but it's not there completely. And working with a non-standard environment like this was slightly more painful than it would be without Nix, actually. But those are edge cases, and you usually don't deal with extreme edge cases like that. And it's still possible to solve, it's just slightly more complicated. By the way, this uses Phoenix as well, I think, or Oxalica, I'm not sure now.
Both were great.
Since about 2 weeks ago, the Extensa targets have been upstream into the Rust environment.
Yes.
But the LLVM patches will take years.
I think that's it's already merged in something. It's already merged into
yes,
LLVM.
some of it is already merged, but they have a lot of patches.
Also, just to go back with it, the NCI actually uses the Dream2Nix on backend.
That's really nice. Dream2Nix, we've done it for Python stuff. Works quite well.
Okay, so brings us to. It's a so if you so are you asking about Nix or Nix OS? Those are two. Nix as a package manager. Well, it both has the same learning curve, I'd say. So, depends. Like if you are used to learning new programming languages and new approaches, and if you are a fast learner, I would say that like in a short time you should be able to, in few weeks you should be able to do everything I'm doing here. I went with flake parts as a recommendation and NCI and stuff because they are quite well documented and they don't have that high entry barrier, I'd say. But on the other hand, I came to them after some months in Nix, so it might be you might have a different experience. But the part where it's quite opinionated and does think only one way makes it quite easy to start with it. I also have other links here, which are quite nice. I don't know if you know Faster Than Lime from the Rust community. He's quite a Rust celebrity, I'd say. And he has a really nice series of articles because he's a huge Nix enthusiast as well. And he has a really nice series of articles about building Rust service with Nix, which goes all the way through the development of the Rust service from the scratch, from the first rows and everything. It's really nice. It's really comprehensive. It does things differently than I did. He also had like 12 parts or 12 articles to do that. So he goes in more raw Nix way and in like with like basic tooling, but doing it. Basically, the thing that some tools that I showed are shielding you from he's using them directly. So I wouldn't say that it's a better approach, it's a good approach, but we would be here tomorrow still, I think. Other nice part is Nix builds, which is, I'd say, one of the best official documentation things out there. It takes you through the whole Nix language and how to work with it, and the language itself, how the language works, how to program in it. I'm low-key considering doing next advent of code in Nix.
By the way, is it somehow hugely different between backing Rust or, for example,
Now that depends on your tooling as well. For example, the Dream2 Nix libraries that I talked about, they are quite, they are trying to hide the complexities and do everything the same way. Obviously, that makes it slightly harder to do specific stuff. I did build like 2 C++ projects with it. It's not that hard. Like you have, you basically specify a build phase of Nix package, which you can do as a bash script where you just input commands that are necessary to build it, stuff like that. So, yeah, it's not hard. I wouldn't say that it's harder than, for example, creating an e-build or package build.
I think that the thing most people struggle with is that Nix is a programming language and not a configuration format. So you need to look at it as functions that you are applying and that you can build abstractions for yourself that you can reuse and make things easier for you.
It doesn't necessarily help that the thing that you see here kind of looks like JSON.
Yeah, that's a function.
That's a function, yes. The outputs equals. This is the anonymous function.
Yes, it's the body of the function and that's the attribute.
It's actually one attribute.
That's argument destructure. Yes.
Because all functions in Nix have only one argument.
Yeah, but it's destructured, like
It's fun.
This begs the question why people call it declarative if it's function.
good question.
I mean, many people say it's a declarative way of building the
It's a declarative way to install Air packages with a functional language.
all right.
Some people do random code with Nix because it has a standard library. You can do things, you can read files.
I said it. I wanted to do next advent of code in Nix because, like, why the hell not? It really helps if you are used to other functional languages like Haskell, for example, because I'm not a Haskell developer, but I've heard that that Haskell users are right at home with Nix.
because last time I played with Nix, it was the Nix environment, something, I don't remember exactly, but the thing was I wanted to update some packages and allocated like 2 gigabytes of RAM, just the Nix package manager. Is that a normal thing? And it takes forever.
Yes, that's kind of sounds like you didn't have because Nix is on its own. It's a source-based package manager, like Gentoo, for example. So it doesn't have binary packages. It only has cache. So those derivations that you've seen, the long hash and stuff, those hashes are stored somewhere and with the build outcome, and you can your package manager can look up that hash in a cache, and it can download it. What you said kind of sounds like it started compiling stuff.
No, that was not the case. I think it was the Nix daemon, the central thing.
So okay, that's weird. That's something went horribly wrong, but I can't tell you what.
Okay.
If you have an idea or some other Nix user here, but never heard about it.
Okay, thank you.
Where are actually the dependencies coming from? Because the shared object dependencies is like every operating system has like different flavors of those. And so where would it come from? So because it's an OpenSSL from Debian is different than an OpenSSL from Ubuntu, for example.
Well, you have Nix packages, which is like this huge repository of all packages that are used in a Nix operating system as well.
So it's maintained within Nix. They have their own variation.
Yes, they are packaging all of that, and if you take a look at NixOS Nix packages, it's a huge repo. It's one repo that contains basically everything. So if you want to update a package there, you just create a pull request of that specific package, and someone hopefully will take it and work with it.
And it's also, it's just pre-compiled packages there. Or are there also source packages?
No, they are only source packages, basically. Well, in Nix packages itself, in the repository, you have only the prescriptions of how to build it. So basically the Nix programs that tell you how to build your packages. As I said before, you have Nix Cache, which is something completely different. It's a web service that basically hosts all of those packages basically when your system or when your package manager is connected to the cache, and it creates the hash of the derivation, so the long hash, everything. It looks it up in the cache. It matches the hash. If it matches, it will download the binary build. But obviously, you can, if you change anything in it, and Nix makes it, that's one of the advantages actually. You can easily, because it's just like build prescription, you can easily change any parameters of that build. You can change the build process. For example, I found out that one of the packages that I have doesn't work in some way with my hardware, and that there is an upstream patch already, but it still wasn't released. So it took me like 2 minutes to bring that patch into my operating system, build it with it, and it was there. But obviously when you do that, you automatically lose the cache because.
Yeah, of course. If you're customizing, you're customizing.
Well, if you are lucky, someone built it the same way and cached it, but usually not.
Okay, so let's thank Kate for her presentation.
Thank you.
I have to say I'm still quite scared of Nix, but now at least I know more about it.
I'm still scared of Nix. So. that's a good approach to that.